So full disclosure, I'm still pretty new to the Linux world, and for a while now, my system has been putting me through a recurring annoyance. Here was the weird quirk. If I just turned my laptop on for the day, it was a gamble. Maybe 1 out of 5 times the Wi-Fi wouldn't show up. But if I ever dared to reboot my machine, game over. The Wi-Fi icon would just vanish. No networks, no adapter found, just complete radio silence. And for the longest time, I had absolutely no idea how to fix it. I had to reboot my system again to fix it. Now, because I'm a beginner, I didn't even know where to start. So I actually turned to Gemini to help me figure this out. It suggested a classic tech support move: kick the network service. So I opened up the terminal and typed sudo systemctl restart network manager and hit enter. And absolutely nothing happened. The service restarted perfectly fine, but my hardware was still a total ghost. I realized that kicking Network Manager only works if the software itself is frozen. My problem wasn't the software, it was running a whole layer deeper. Since the easy fix failed, I had to dig into the kernel logs using dmesg to see what my Realtek card was crying about. And right there, I found the reason. Mac power on failed and failed with error 16. I had to look up what error 16 meant, and in human English, it means device or resource busy. My Wi-Fi chip had essentially locked itself into an electrical coma, and it was completely ignoring the operating system. Trying to fix this forced me to learn how Linux actually boots up, and it's basically a high-stakes corporate relay race. First, the BIOS and grep wake the machine up and hand control to the Linux kernel. The kernel's job is to load kernel modules, which are essentially on-demand drivers stored as kernel object files, so your physical hardware can talk to the operating system. Once the drivers are loaded, systemd kicks in to launch your background services, eventually starting Network Manager to connect you to the internet. I also learned that Linux drivers are split into modular layers, so developers don't have to rewrite code. When I ran lsmod, I could see a whole stack of Realtek driver layers relying on each other like a tech version of Jenga. I will spare you the full list, but the core structure looks something like this. Here is where the drama happened. Linux has an aggressive power saving feature called active state power management. The kernel told my Wi-Fi card to take a quick nap to save electricity, but the chip's firmware got deeply confused. When I rebooted, the driver screamed at the chip to wake up, but the chip hit the snooze button through that busy error 16 and refused to draw power. Because that driver failed to initialize, Network Manager finished booting, looked down at the hardware layer, saw absolutely no active Wi-Fi driver to talk to, and just gave up. My first instinct to restart Network Manager failed because the software was literally shouting at a dead link. Because the chip was completely frozen, my only workaround was ridiculous. I just had to reboot the machine again. The first reboot would always kill the Wi-Fi, but somehow a second warm reboot would shock the motherboard and PCI slot back to life. But I didn't want to play this double reboot guessing game every time I turned on my laptop. So I found a permanent fix, that is to tell the Linux kernel to stop letting my Wi-Fi card sleep on the job. I hopped into the terminal and created a dedicated configuration file under /etc/modprobe.d/rtw88.conf. Inside this file, I typed options space rtw88 underscore PCI space disable underscore ASPM equals to Y. This commands the kernel to completely disable that aggressive power management for the Wi-Fi card, keeping the link stable and awake. I saved the file, gave the laptop one final reboot, and just like that, the kernel read the new config on boot and blocked the card from ever falling into that power coma again. My Wi-Fi has been rock solid ever since. Thought I won. My Wi-Fi was rock solid for days, and I felt like an absolute Linux genius. Until I did a routine system update using the DNF package manager, restarted my laptop, and bam! Back into the void. The ghost has returned, and I felt completely betrayed. I had officially fallen into the kernel update trap. To see what went wrong, I jumped right back into the terminal to check if a new kernel has snuck in. You can verify if a new kernel broke your configuration chain using this command: rpm space hyphen qa space hyphen hyphen last space pipe space grep space kernel hyphen core. Look at the top line. If the installation date matches the day you ran your recent system update, a new kernel version was added. Here's why that happens. When DNF installs a new kernel, it automatically builds a fresh initial RAM file system for it. But for tricky drivers like RTW88_PCI, this automatic rebuild sometimes doesn't properly carry over the custom power management tweak we set in modprobe.d. So the new kernel boots with the driver in its default broken state. To manually force a clean rebuild and bake my Wi-Fi fix into the new boot sequence, I crossed my fingers, opened the terminal and ran sudo space treecut space hyphen hyphen regenerate hyphen all space hyphen hyphen force. I gave it a minute to finish, restarted the laptop, and breathed a massive sigh of relief when the kernel finally read my rule and brought the Wi-Fi back online. Like I said at the start, I'm still learning the ropes of Linux troubleshooting, so tracking this down felt like a massive win for me. Since I'm a beginner, if any Linux pros out there notice I oversimplified something or missed some nuance about anything, please let me know in the comments. I'm making these videos to document my journey and learn from the community. If this helped you out or you just enjoy watching a beginner wrestle with a hardware bug, hit that like button, subscribe, and let me know what hardware is currently giving you a headache. See you in the next one.